Good morning, everybody, and welcome to today's DrayTek webinar. This is a continuing series of webinars that we call DrayTek in 45. This is quite a deep dive webinar into some of the technical aspects of our switches, and we're calling this switch security features. So for those of you that are quite technical, we think there'll be a lot of really good information for you in this webinar today. For those of you maybe not so technical or looking at DrayTek in the early stages or for the first time, there is quite a lot of detail in this webinar, but just to say that it is all recorded. You do have an opportunity to ask questions, and you can stream this after the event if there's any particular bit that went a bit too fast. So I hope that kind of makes it clear. So I'm Julian, I head up sales for DrayTek UK, and joining me today, and the individual that's going to be doing the vast majority of the speaking, is one of our technical specialists, Mihai Cretu. So just to summarise what this webinar is all about and who it's aimed at, this is designed for all our reseller partners and also our end users as well. So if you're a user of the product and want to know a little bit more about how to set the thing up properly, or maybe you're a reseller and want some good background information about where this product can be positioned and where it can be used, this is just the right thing for you. As I said to you, it is quite a technical deep dive. And as Mihai will explain, we go through a number of aspects of DrayTek switch security. So this will probably appeal to the more technical of you, but as I said earlier on, this is recorded and you'll be able to see it a little bit later on. This will be actually placed on our draytek.co.uk website in the video section. And after this session today, we will write you all individually by email explaining where you find the link and how you can stream this after the event. So as I said, please do ask questions using the chat function, and as I said at the end, we will have a bit of a summary at the end as to what we've kind of all learned, and we will summarize those top 5 or 6 questions that have been asked. So without further ado, I'll get you onto the real expert now, Mihai, who's now going to take you through switch security. So Mihai, over to you.
Thank you very much, Julian. Hello to everyone out there, and thank you for joining this webinar. I hope you are doing well. And before we move into today's agenda, I want to thank you all for the positive feedback that you have given me on the previous presentations. And I'd like to mention that part of today's switch security presentation is not available on our entire our entry-level or mid-range switches. But some features are obviously available on our entire switch estate, such as port security and few more. I do recommend to check the switch comparison chart available on draytek.co.uk. Anyway, my colleague will also send you the relevant links at the end of this presentation. We'll be looking at a bit of introduction to switch security, port security, storm control, denial of service, few interesting features that are available on our DrayTek estate. Let's quickly move to switch security and types of switch security. Just to start with, in terms of security, from a networking perspective, nothing is basically 100% secure or can be considered 100% secure. Therefore, knowing this, we can only improve security and come as close as possible to that 100% secure figure. For instance, we have physical security. The name says it all. This requires a network administrator to physically secure the switch in a cabinet. And obviously, the cabinet should be locked with limited access for non-admin users. Basic due diligence security. This includes changing the default passwords, keeping the switch firmware up to date, disabling Telnet and HTTP since both don't offer encryption when used. Any unused switch ports must be disabled, and very important is to document whatever is going to be connected to each port on the switch whenever this is possible. We also have AAA services, authentication, authorization, accountability, which is the primary and recommended method for access control, I'd say. All management access, such as SSH or HTTPS, should be controlled with AAA, radius being the widely used method. It is going to be covered on this webinar at 802.1x authentication. This extends to creating user accounts for each network admin that will access the management page of the switch, also called administrative access. We have broadcast security, or VLANs. So dividing a big broadcast domain into smaller broadcast domains, first of all, increases the network performance. And by doing this, you can increase the network security as well, since the guest VLAN, for instance, can't talk to the main VLAN, reducing potential unwanted broadcast leakage. And we have the DrayTek security features, such as port control, storm control, denial of service defense, dynamic ARP inspection, DHCP Snooping, IP source guard, and this one missing in there, which is IP conflict prevention. Regarding this feature, we have previously dedicated an entire webinar for it, and it was held by my colleague, Amy. So please do refer to that video to gain a better understanding on how to use this feature. So let's move now to switch security, port security. What port security is? Well, this method both ensures that broadcast multicast data is kept to a minimum, while still allowing critical services that rely on the broadcast transmission to still work. Since creating loads of VLANs and rules can be time-consuming, unscalable, and overly complex, or may not be needed at all, the port isolation feature takes all the pain out by keeping port traffic separate. Once you enable isolation on various switch ports, layer 2 network traffic will not be forwarded between them. This means, as an example, you can have a single guest VLAN servicing all the hotel rooms and still keeping the traffic between the guests in different rooms completely segregated, although they are residing in the same VLAN. Basically, this is the easiest way to protect the LAN environment. It isolates port entirely regardless of the VLAN they are on. No communication between ports means no virus spreading, no attacks. So you might wonder, what's the difference between VLAN and protected ports? Well, VLAN, it's used to isolate the entire broadcast domain. A VLAN, it's a broadcast domain, basically. Protected ports is to isolate different interfaces within the same VLAN. So on a broadcast domain, we have loads of users, and the VLAN protects all these users from outside attacks, whereby inside that VLAN, we have no protection. It's where the isolate ports comes in handy. So how the communication between protected and unprotected ports work? So protected ports, the ones that are protected already, can only forward traffic to unprotected ports, whereas unprotected ports can forward traffic to both protected and unprotected ports. In this case, it's very good to consider a scenario whereby there is a printer installed, and obviously we need to omit in adding this port to the protected port list, since the user won't be able to use the printing services anymore. So let's quickly have a look on how we do that. But before we go into configuration, just to let you know that today's webinar is only on switches, so our practical demonstration has only switches. So let's log into the switch, navigate to switch LAN, port settings, and select protected ports. This is really easy to enable. All you have to know is which ports do you want to isolate. I therefore selected all these ports and enabled protection. If you can see here, we have general settings as well on the top of protected ports on the left-hand side. And in there, you can disable switch ports that are not being used. We can now move to storm control. Let's quickly have a look to understand how storm control for managing traffic level works. So basically, what a storm control is generated usually when messages are broadcast on the network and each message prompts a receiving node to respond by broadcasting its own message on the network. This, in turn, prompts further responses, creating something like a snowball effect. In that moment, the LAN is suddenly flooded with packets, creating unnecessary traffic that leads to poor network performance or even a complete loss of network services. What Storm Controls does is enables the switch to monitor traffic levels and drop broadcast, multicast, or unknown unicast packets when a specific traffic level is being reached, thus preventing packets from degrading the LAN. Referring to these graphics, first things first, we need to identify where it's suitable to enable storm control. We don't want to have that enabled on the voice VLAN. For instance, since on the voice VLAN, we only have IP phones with a predetermined behavior on the network. But it makes more sense to have that enabled on the switch where the users are residing. Also very important to identify what traffic should be expected on a switch port. For instance, are we expecting streaming heavily on that port, or data transfer between a network storage and a device connected to that port? Guys, if you don't know what kind of traffic is to be expected on a switch port, you should skip this feature altogether, since it might not be suitable for all environments. So let's have a look on how we do that on DrayTek switches. Back onto the switch, we are now moving to security, and underneath we have storm control and properties. Select properties, and then we select the storm control mode as kilobits per second, and we exclude preambles from this process since that's not needed. After that, we can just navigate to port settings, select the ports that we would like to enable storm control on, enable the storm control, setting the broadcast, unicast, and multicast traffic with the thresholds, and set the action to drop. Well, what happens if the threshold is reached? We want to drop whatever comes after, so we don't want to shut down the port entirely. We just want to drop traffic that exceeds the threshold that we put in there. This is the reason why I also mentioned earlier, if we really need to know what traffic is going to be mainly on a port. So if we don't know that, we won't be able to set the broadcast, unicast, and multicast properly as the threshold. I hope that makes sense. So let's move to denial of service and what denial of service is and how we do set up on a DrayTek switch. A DOS attack basically prevents users from accessing a service by overwhelming either its physical resource or network connection. The attack essentially flows the service with so much traffic or data that no one else can use it until the malicious flow has been handled. One way to overload those services' physical resources is to send it so many requests in such a short time that it overwhelms all the available memory, processing, or even storage space. In extreme cases, this may even lead to damage of the physical components of the machines in cause. Similarly, a DOS attack can send invalid, malformed, or just overwhelming number of connection requests to it. While these malicious requests are being addressed, connection requests from legitimate users can be completed, leading to denial of service. Some malware also includes the ability to launch DOS attacks. When they infect a computer or device, these threats can use the resources of the infected machines to perform the attack. When multiple infected machines launch attacks against the same target, it's known as a distributed denial of service attack, and we want to avoid that. Let's quickly have a look on how we do that on the switch. By the way, guys, this section requires you to do a bit of research on on all the available defense tools that are in here. And obviously take a decision which one is worth enabling and which one is not. So under DOS properties, we have the entire denial of service defense tool palette. So if I take by randomly what is ping of death, for instance, well, ping of death is a type of DOS attack in which the attacker attempts to crash, destabilize, or freeze the target computer or service by sending malformed or oversized packets using a simple ping command. In this case, the switch has the ability to detect such an attack and stop them. We basically have to look at this not only thinking that a user on the LAN will create this kind of scenario, which might be rare, but rather a virus that is doing this without the knowledge of the user. So after we enable the wanted services, we can move to DOS port settings. And obviously, select the ports that you would like to apply DOS to. Enable DOS protection and press apply. Let's move to dynamic ARP inspection right now. So I will call this DIE because it's quite a long name. So DIE basically is a security feature that validates ARP requests or address resolution protocol packets in a network. Also, DIE allows a network admin to intercept, log, and discard ARP packets with invalid MAC address to IP address bindings. This capability protects the network from certain man-in-the-middle attacks. To prevent ARP poisoning attacks, such as the ones described in the previous section, a switch must ensure that only valid ARP requests and responses are relayed. How this works is, so the dynamic ARP inspection associates a trust state with each interface on the system. Packets arriving on a trusted interface can bypass the DIE validation checks, while those arriving on untrusted interfaces go through the DIE validation process. In a typical network configuration, all ports connected to host ports are configured as untrusted, while all ports connected to other switches or uplink to the router is to be configured as trusted. Therefore, we have this scenario in which the left-hand side laptop is doing an ARP request with the destination of the router. Instead of router responding, a malicious ARP response is coming from an infected PC on the network. Well, the switch is going to identify that threat, and it's going to redirect the traffic to the correct receiver. Let's have a look on how we implement that onto the switch. Back to security, under dynamic ARP inspection, on the properties global settings, we select the available VLANs or the VLAN that we want to apply dynamic ARP inspection on. Enable the state, and then move to per port property settings. We are selecting the untrusted ports, or the ports that basically serve end users. Selecting that, selecting source MAC address, destination MAC address, IP address, and allowing a default route as well as the inspection process is very important. After we set our untrusted ports, we can then select our trusted ports. And now let's move to DHCP Snooping. This is a very important topic. I will tell you later why. But let's quickly have a look on what is dynamic host control protocol snooping. It's basically a layer 2 security technology built into the operating system of a capable network switch that drops DHCP traffic determined to be unacceptable. The fundamental use case of DHCP snooping is to prevent unauthorized or rogue DHCP servers offering IP addresses to DHCP clients. Rogue DHCP servers are often used in man-in-the-middle attacks or denial-of-service attacks for obviously malicious purposes. So what the DHCP snooping is going to drop? It's going to drop DHCP messages from a DHCP server that is not trusted. Trusted DHCP servers are identified by configuring a switch port DHCP snooping trust state, like we did earlier with the ARP, dynamic ARP inspection. Then the DHCP message where the source MAC address is embedded, client hardware MAC address do not match will also be dropped. Imagine that someone enables a DHCP server on the network or plugs a router that has the DHCP enabled on it. If that's the case, both DHCP servers will stop working, resulting in downtime for users. So what happens when a DHCP snooping violation occurs? Well, the DHCP snooping service detects a violation, the packet is being dropped, and the message is being logged. If you wonder where should you deploy DHCP snooping, then from a networking design perspective, DHCP snooping is an access layer security feature. Therefore, any switch containing access ports in a VLAN serviced by the DHCP is a potential client. So any port that serves users, it's a potential client. Let's quickly have a look on how we enable DHCP snooping on DrayTek switches. We go to security, DHCP snooping, properties. We again select the VLANs that we want to apply the DHCP snooping on under the global property settings, and then move to per port property settings. Again, we have to select the trusted port. So for instance, if your DHCP server resides on the router, then the uplink to the router should be the trusted port, and select trust and apply. Then you select the untrusted port with the verify inspection. And now let's move to IP source guard. So what IP source guard is a security feature that restricts IP traffic on untrusted layer 2 ports by filtering traffic based on the DHCP snooping binding database or manually configured IP source bindings. This feature prevents or helps preventing IP spoofing attacks when a host tries to spoof and use the IP address of another host. Any IP traffic coming into the interface with a source IP address other than the one assigned via DHCP or statically configured will be obviously filtered out on the untrusted layer 2 ports. This feature is enabled in combination with the DHCP snooping feature on untrusted layer 2 interfaces. It builds and maintains an IP source binding table that is learned by DHCP snooping or manually configured. An entry in the IP source binding table contains the IP address and the associated MAC and VLAN ID. Let's quickly have a look on how we configure the IP source guard on our switches. Back onto the switch, on the security IP source guard, on the port settings, we select the ports that we want to enable the feature on. We enable it, and the verify source should be set to both IP address and MAC address. Applying that should enable the feature on the selected ports. Now let's have a look to 802.1x authentication. This is my preferred method of switch security, to be honest. Let's quickly have a look what 802.1x authentication is. And simply put, it provides an authentication mechanism to devices wishing to attach to a LAN or wireless LAN, basically. Implementing 802.1x network security on an enterprise network, or even on a home network, protects data and equipment from cyber attacks. The idea that someone could launch a cyber attack from within your network is quite real. That's where the 802.1x network security protocol comes into play. 802.1x network security provides protection from someone walking in, connecting a rogue device to your network, and releasing a virus, malware, or a man-in-the-middle attack. Put another way, firewalls help protect from attacks originating outside the network, and 802.1x help protect from attacks originating within the network, since all users must be authenticated first before accessing local resources or the internet. It was originally designed to address wireless LAN access security concerns, and it was later adopted for wired Ethernet ports as well. Looking at the graphics in front of us, and traditionally a PC, when connected to a switch, is going to do a DHCP request. It needs an IP address to connect to the internet. The switch is going to instead send an EAP request to the device. The device is going to respond with the its EAP identity, moment in which the switch is going to send directed traffic to the radius server. The radius server is going to challenge by asking a username and a password. The switch relays that back to the client. The client responds with its own credentials. The switch sends that to the radius server. If the radius server accepts the credential, it's going to send an extensible authentication protocol success message, moment in which the PC is able to access local resources and beyond that. So this is today's scenario. We have the user requesting access. We have a router connected to the internet. We have several servers that are running on the network, file server, mail server, and obviously a radio server. However, DrayTek routers can act as radio servers as well. So you can find those settings under applications on most of the DrayTek network devices, routers mostly. Since, if you don't have a third-party radio server, but you have a DrayTek router, you can use that as your radio server. So let's quickly have a look on how we do that on the switch. Logging into the switch, we go to security, and under radius, we have to add the key string that was originally set on the radio server, apply that setting, and underneath, we should add this radio server IP address, and the preferred method obviously is going to be IPv4. So this is how you point the switch to the radio server initially before you perform the 802.1x configuration. So now let's have a look on how we configure this. Back onto the switch under security, 802.1x authentication on the properties. We have the authentication type. We set that as 802.1x on the global settings. And then we can move to port authentication settings. In here, for today's webinar, I applied the settings just to one port, port 14. As you can see, the authentication type enabled for that port is 802.1x. And the host mode is set as multiple authentication. So this works if you have an access point connected to port 14 and all the wireless clients connected to that access point are authenticating via 802.1x. Then it makes sense to leave that port as multiple authentications. If not, you can leave it as one host, basically authentication. Underneath, we have the available authentication tool, and I have disabled the radius VLAN assignment. Next step. Underneath, on the 802.1x authentication, we have port control settings. So let's quickly enable port control for port gigabit 14, and the port control should be set to auto, always. At the bottom now, we can see the port gigabit 14. It's enabled and the port control is set to auto. Now, let's see if we successfully authenticated any hosts. So moving to authenticated hosts under the same menu, we can obviously see on gigabit port 14, we have an 802.1x authorized user. Moreover, you can go and check the switch syslog as well. The switch has a syslog explorer in case you don't have a syslog server. So moving on to syslog diagnostic, syslog explorer, we can obviously see the category as authentication manager and the message as 802.1x authentication successfully for client connected to port 14. So this is how you increase basically the switch's security. Moreover, we have access control lists available on the switch. So let's quickly have a look on what access control lists are, when to use it, and how to configure that. Basically, ACLs is a set of rules that is usually used to filter network traffic. ACLs can be configured on a network device with packet filtering capabilities, such as routers and firewalls. And in our case, the DrayTek switch can do that right before the traffic reaches the router. In this way, increasing the network performance. ACLs usually contain a list of conditions that categorize packets and help the switch determine when to allow or deny network traffic. They are applied on the switch interfaces to packets leaving or entering the interface. Both types of ACLs are available on DrayTek switches and routers as well. The engine behind, or the engine enforcing the ACL, starts at the top and moves down to the list, meaning that if you have a block all as the first rule that has been created, any potential allow rules underneath are going to be ignored. For best practices, use a deny all rule at the end of an ACL, never at the beginning. This being said, on our switches, a deny all rule is automatically added by the switch when you create a one-off permit rule. I will show you in a second how that works. And obviously, purpose of ACLs is to prevent information leaks and unauthorized access of resources on key servers at home or at work, and to limit access to certain services on the same LAN or beyond that on the internet. For today's example, we will be using MAC address ACLs, basically. However, the switch is capable to do IPv4 and IPv6 ACLs and service-type ACLs, meaning that you can restrict or allow TCP ports as well. We therefore have this scenario in which we want to allow PC1 to access the router's web interface, and no one else on the network should be able to do so, pointing that everyone is on the same VLAN, so potentially they can access the router. But by using ACLs, you restrict the access to the router just to one MAC address. So let's quickly have a look on how we do that. Under switch security, ACLs, we need to create an ACL. This is basically a MAC ACL, and all it takes is to give it a name. After you have done that, you can move to create an access control entry. So we have created the ACL, now we create the access control entry. And here is where we select the ACL profile that we created in the previous step. We set the sequence to first, which is number 1. Action is going to be set as permit. And then we edit the source MAC address, which is the PC1 MAC address, and the destination MAC address, which is the router's MAC address. And as you can see, the action is set to permit. And we can add this rule. Checking at the bottom, on the available rules, we can see the test ACL rule is successfully applied, and the switch automatically applied the deny all rule at the end of this setting, meaning that just that MAC address is going to be able to access the router's web interface whereas everyone else is not going to be able to do that. All right, so now you have configured you have created an ACL, you have created an access control entry. Now you have to bind that to some switch port or apply that to the switch ports. So as a last step, we go to ACL bindings, and we want to specify on which ports are we going to apply the MAC ACL. And then underneath, we can visualize if that MAC ACL is applied to the requested ports. Just to recap the steps taken so far, we have looked at port security and storm control. We did some DOS defense and DHCP snooping, some dynamic ARP inspection and IP source guard, and 802.1 authentication and ACLs. There is some powerful insights when referring to DHCP snooping, because having this enables other security features to take decisions in the network. For instance, both the dynamic ARP inspection and IP source guard are using the DHCP snooping's database to take further security decisions. Why is that, you probably wonder? Well, because the DHCP snooping database keeps a track of loads of things in the network, such as who is connected where, what's their IP address and MAC address, what's the DHCP list time. Sometimes hard to counterfeit details. Therefore, the DHCP snooping, along with the 802.1x authentication, will be our highlights of the day. So now I want to thank you all for taking part of this presentation, and I will hand over to my colleague Julian to talk you through the Q&As.
Yeah, thanks very much indeed, Mihai. Excellent presentation. We did promise everybody a technical presentation. I think we delivered that. So hopefully that was really good for those of you looking at finding more technical information on our switches. But as I say, there is quite a lot of resources available here for you, and also this webinar was indeed recorded, which we'll give you details of later. So first of all, there's a Viga switch product guide with a security section. So obviously that's quite a long, complicated URL. You will get a link in this in the email that we send to you. So that's well worth looking at to look at the security section on in our product guide part. There's also a really good switch comparison chart. So if you're wondering, which particular switch should I recommend? Which ones have PoE? Which ones are managed? Which ones have the 8, 24, 48 ports and so on. There's a really good comparison chart there that's easy to see when you go onto the DrayTek website. I know a lot of customers I know do use that. And then there's I know we did a bit of work on the internal radius server there. There's quite a good support article there, which I think you'll find quite useful if you want more information on that. So that's that. There is more to be had, as you know, on the knowledge base, but I hope that will give you some really good supporting information following the webinar today. Okay, so that's we're now going to kind of wrap up, and we're going to do a bit of a kind of open Q&A, just looking at some of the key questions that come out as a result of the webinar today. So I think I'm going to ask Alex to join me, Alex, who's our CTO, who I believe may have summarised some of these questions we've had, and we can do a kind of Q&A kind of live right now. So Alex, hoping you're going to come in right now.
Hi, Julian.
Hi.
Thanks very much, and thank you, Mihai, for the good presentation. So yeah, got some questions that are coming in. I see people have started to ask a lot more at the end as well. So we'll be continuing to answer those over the text, but also we should be able to answer some of those now over the audio. The first question I have is related to how do you get notified of events? So if people are enabling some of these functions.
You there, Alex?
Yeah, guys, I think we have.
How do you receive alerts? Can the switch notify you that there's something to do with the ACL or kind of events there are?
Alex.
Mihai, can you hear me?
Yes, I can hear you. So I think I understand the question.
I think we may have some audio difficulties coming in from Alex, which does happen when we're all in a home working environment. So hopefully you understood that question, okay, Mihai?
Yes, absolutely.
Yeah, so just hold on. So Alex, wonder if you could just mail me those questions and I'll ask them to Mihai. Alex, you're having difficulties on the audio. So apologies for that, everybody, but over to you, Mihai.
Yeah, so probably this is in regard if you can set up an mail server to receive notifications about network events, and the answer to that, yes. Actually, all our switches support that, so you can have an email alert set on the switch and on the routers as well.
Yeah, okay. I know there's a common question that does come up on our switch range when we do a kind of webinar. I think a couple of people have asked it, and I think I'll just sort of reiterate it now. So I know if you look at sort of particularly PoE switches in the market, you can have like a 24-port switch, an 8-port switch, a 48-port switch, and so on. Some don't necessarily support all ports on PoE. But what I can confirm to you is that the PoE switches that we provide, there's an 8, a 24, and a 48-port version, all have a very good wattage backplane to it, and indeed every single port can be used for PoE. You need to obviously check the overall wattage coming from the device to make sure you're not massively overloading it with lots of IP cameras or something. But if you buy a DrayTek switch, generally you can use all ports for PoE, for the PoE versions. I know that's a question that does come up quite a bit. So I don't know, Mihai, obviously I think we seem to have lost Alex. Do you have any other sort of typical questions you think you may want to raise, Mihai? Obviously, as you're going through the presentation, I know quite a bit kind of came to mind. Is there anything you want to maybe raise as a typical question we could just cover in this open forum now?
Well, not at this time. Would be good. Yeah, so would be good if before deploying any of the presented configuration today, it would be good to have a look to this video again, and also to do a bit of research on something like DOS defense, yeah, because there are so many options in there that we have, and sometimes some of these options might not work for us because it might block something that we don't want to block. So it's always good to do research before deploying any of the features presented today, but most of them should be like quite straightforward, such as port security. You isolate ports, and therefore no virus can multiply on the network because all the ports are isolated. So that's quite easy and to apply to a network configuration, basically. But no, I think we're gonna get so whoever had a question is gonna receive an email anyway.
All right. So just one question for me. I know that this comes up quite regularly, is with regard to the management of the switches. And I think when you were doing the webinar today, you were basically going into the switch interface, weren't you? So going into you were showing what it looks like to log into a switch and make those changes. Maybe could you just comment a little bit on more management of those switches? So obviously you can go into the switch. I think you can manage it via the router, and obviously we've got the ACS system as well. Do you want to just comment a little bit on that so individuals will know what the management options are? I mean, I think particularly if you've got lots of switches deployed or maybe multiple sites or something, that might well be of interest to people today.
Yeah, absolutely. That's a very good question, actually. Gillian, maybe I should have covered that earlier. But indeed, there are so many available management tools. So you firstly have router-based management, in which you can use the router's web interface to apply VLANs and configuration to the switches. But for a more complex or full-on management solution, we have Vigor Connect, which can basically manage switches and access points only, and ACS management, which is the cloud management solution, in which you can manage your entire DrayTek estate, meaning that switches, access points, and routers. And you can do these changes that we spoke about today via these management tools, ACS, for instance. You have full visibility of the switch on the cloud platform. So if it needs be to power cycle a port because it's a device that's not responding on that port for some reason, you can quickly log in onto your account and see what's connected to that port and power cycle that port in the hopes that the device is going to come up. Or why not, you can create the VLANs from the management platform. You can create your trunks. So basically you can do everything that we have done today on the switch. You can do it via ACS instead.
Yeah, so yeah, well worth noting that. I think also for everybody on the call today, typically you're putting a switch in probably in combination with other things. You may be using a switch in combination with the router, or you may be using a switch, a PoE switch in combination with access points to put in Wi-Fi and so on. I think it's important to note that you can manage a router, an access point and a switch from the router. You can also manage it through the other management tool platforms we've mentioned as well. So well worth kind of considering that if you're interested in deploying these a little bit further than we've discussed today. Okay, Mihai, unless you've got any particular questions that come to mind, those are sort of classic commercials that come up time and time again. Before we wrap up, any other questions that come to mind, Mihai, and we can move on?
No. I would recommend everyone that has a question to just address it on the chat, and we're going to respond to them.
Okay, well, thank you very much for attending today. DrayTek in 45, I think it was DrayTek in 47, so we only just slightly overrun. So thank you very much for being with us today. We really hope you found that useful. Please do use all those resources, and please do give us feedback. It's really a result of all your feedback you give us and all the conversations we have with you day in, day out, that create these types and styles of webinars. So any feedback you've got on things you liked or things you'd like to see next time, please do let us know, and we'll endeavour to augment and improve as we go through the months. Thank you very much. Have a good day, keep safe, and we'll speak to you soon on the next webinar. Thank you very much indeed. Bye now.
All the best, everyone.